Hi dear students, I think you studied the first part very well. Is this okay? Yes, now we will discuss the second part. Second part, which is the second part? Yes, projectile motion. It is a two-dimensional motion. What is the two-dimensional motion? Yes, it is in a plane. Motion in a plane. Projectile motion. Projectile motion means a body thrown with an initial velocity and then allowed to move under the influence of gravity alone. Under the influence of gravity alone, then the motion of the body is called projectile motion. We just throw a ball with an initial velocity and become free. The only force influencing is gravitational force. Then the motion of the ball is projectile motion. The ball or the body is called a projectile. Projectile is the body. Projectile. Okay. Projectile is the body which is projected. It is a very common motion in nature. We can see many projectile motions. For example, if an athlete throw a javelin, it moves in projectile motion. What is the path? How we can draw the projectile motion? If we throw a stone from here with an initial velocity u, it is moving like this. This is the path. What is the shape? Yes, it is a parabola. It moves in a parabola. The path of the projectile is a parabola. Path of the projectile is also called trajectory. What is called a trajectory? Trajectory means path. Trajectory means path. Remember, the trajectory of a projectile is a parabola, or the path of a projectile is a parabola. Okay? It is a long time taken to prove the path is a parabola. So earlier someone thinks the body moves like this in a straight line towards upward and moves downward, vertically downward. But because we cannot see the path like this, it is only with the help of mathematics we prove that projectile motion is a parabolic motion. The path of a projectile is a parabola. Okay. Then what is the projectile motion? A body thrown with an initial velocity and then allowed to move under the influence of gravity alone. The motion is called, the motion of the body is called projectile motion, and the body is called projectile. The path of the projectile is a parabola, or trajectory of a projectile is a parabola. Okay, clear? Very important. Listen very carefully. Very important topic. You can score up to 4 marks from this topic only, this section, projectile motion. Okay. Now, can you say some examples for projectile motion? Some examples. A stone thrown with an initial velocity. It is a parabolic motion, that is, it is a projectile motion. A javelin thrown by an athlete or a hammer thrown by an athlete, it is a projectile motion. a body thrown from a moving train. A body thrown from a moving train. A person sitting outside the train field, it's a parabolic. It is projectile motion. Okay. Suppose a flight is moving, a bomb is released from the moving flight. It is a parabolic motion. It is a projectile motion. Now we can see a large number of examples for projectile motion. Okay. Yes, you can write the examples in your notebook. Now, it is a two-dimensional motion, projectile motion. We want to study detailed about projectile motion, but we can study only one dimension. So, in two dimension, we can split the motion into two one-dimension. That means in two dimension we have both vertical and horizontal component, x and y. Suppose there is a velocity. In the previous class I show that we can solve a velocity v in two dimension into two components. What are the components? X-axis, y-axis. We have a velocity v. This velocity is a vector and a velocity in two dimension. Then it has two components. We can split the velocity into x. Vx along horizontal or x direction. Vy along vertical or y direction. Okay. Theta is the angle made by the velocity with a horizontal. A body thrown with an initial velocity v with an angle theta. Okay. This velocity we can split into Vx and Vy. Okay. You can also write Vx equal to V cos theta. I already note in the previous lesson, please watch. Okay. Vy equal to V sin theta. Vx is called a horizontal component of velocity. Vy is called a vertical component of velocity. Okay. Let us see the projectile motion. Yes, suppose a body thrown with an initial velocity u, making an angle theta with the x-axis horizontal. The path of the body, we can draw the path. Yes, parabolic path. The body moves upward and reaches at a maximum height, and return to the ground. Okay. Here we can see two motion. One is upward and downward. Body moves upward and reaches the maximum height and moves downward. Second one is the body moves through the x-axis and reaches here. This is the horizontal displacement height. This is a vertical displacement height. This is the horizontal displacement. It is called a range. arc. Okay. We can see later what is range, what is horizontal height, horizontal range, what is height. Now this velocity we can split into two components. We can split into two components. This is horizontal component. What is horizontal component? Yes. Yes, we can split the velocity, initial velocity u into two component ux and uy. Ux along x direction, uy along y direction. Theta is the angle between x and u. Okay, we can write ux, we can write ux equal to u cos theta. Ux equal to u cos theta. You studied the resolution of a vector in the last class. Okay, ux equal to u cos theta is called a horizontal component of velocity. Horizontal component of velocity, because it moves the body in horizontally and reaches this point. It moves the body horizontally and reaches at this point. Now uy equal to u sin theta. It is called a vertical component of velocity. Vertical component of velocity. Okay, thus we have two velocity in two dimension. Projectile motion is a two-dimensional motion, so we have two velocity in projectile motion, that is ux and uy. Is this uy bring the body to maximum height and again reaches the ground. Okay, gravitational force has only vertical component, no horizontal component in gravitational force. It is acting vertically downward. If we take at a 90-degree, gravitational force is downward. Horizontally it is equal to 0. So it does not affect the horizontal motion of the body. Gravitational force does not affect the horizontal motion of the body. So the velocity is constant in horizontal motion. What is the horizontal velocity? Yes, u cos theta. U cos theta is constant throughout the motion. U cos theta is constant throughout the motion. From here to here it is same. Okay, but the vertical velocity uy equal to u sin theta is not constant. When the body moves upward, the velocity decreases because the earth pull towards its center. that is called acceleration due to gravity, G. G affect the vertical motion, so velocity decreases up to maximum height and becomes 0. At maximum height, vertical velocity equal to 0, uy equal to 0. We can write it is final vertical velocity, therefore Vy equal to 0 at maximum height, and then it moves downward, then it is in the direction of the gravitation force, so it affects the G and velocity increases, and velocity increases from 0 to maximum. When it reaches the ground, the vertical velocity is equal to the what is the velocity in the at the time of projection. Okay, that is horizontal in a projectile motion. In a projectile motion, we can write the projectile motion is a combination of horizontal motion with constant velocity, very very important point, and vertical motion with constant acceleration. What is the acceleration? Yes, G, acceleration due to gravity. When it moves upward, it is minus G. When it is moves upward, it is minus G. When moves downward, it is plus G. That is the constant acceleration. Thus, the projectile motion can be defined. It is a motion with it is a two-dimensional motion, horizontal motion with a constant velocity. That velocity is u cos theta. It is a constant velocity throughout the motion, and vertical motion with a constant acceleration. So we can apply the equations of motion in vertical motion. You already studied in first chapter the equations of motion. What are the equations of motion? Yes, equations of motion. Can you say? V is equal to u plus at, S is equal to ut plus half at square, v square equal to u square plus 2s. Okay, you must thorough this equation. We can use at any time in dynamics. Okay, it's the equation for accelerated motion. Here the vertical motion is accelerated motion, so we can use this equation v is equal to u plus at. We can replace a as plus or minus g, upward minus g, downward plus g. Okay, S can taken as h, height, vertical motion. Now I will show you the velocities at the different points. This x-axis, this y-axis in a plane. The body thrown with an initial velocity u, and it is split into u cos theta and u sin theta along horizontal and vertical. Okay. Theta is the angle. Horizontal velocity, we can write horizontal velocity ux. Ux equal to u cos theta. It is constant throughout the motion. Suppose we take a point here, ux is horizontally. If we take a point here, ux is horizontally with a constant velocity, constant magnitude and direction. If we take a point here, then also the horizontal velocity is ux. Now we consider vertical velocity. Vertical velocity here is Vy. This Vy equal to, we can use V is equal to u plus at, the first equation. It is a accelerated motion. Thus Vy equal to uy minus gt. A is equal to what? A is equal to minus g for upward motion. A is equal to minus g. Gravitation force is downward and the body moves towards upward, so velocity decreases, and A is equal to minus g. V is equal to u plus at can be written as Vy equal to uy minus gt. Okay, that is the magnitude of Vy decreases, and at maximum height Vy equal to 0. Very important point. At maximum height vertical velocity Vy equal to 0. Then what is the velocity of a projection at maximum height? Is 0? No. Specify vertical velocity only 0. It has one velocity, a constant velocity ux, u cos theta. At maximum height net velocity ux. Only vertical velocity is 0. We can say at maximum height vertical velocity of a projectile is 0. Okay. Then from maximum height the body moves downward, vertical velocity is 0, and the gravitation force pull the body towards the earth, and it moves downward, and then act A equal to plus g. Then we get Vy equal to uy plus gt. Velocity increases downward. This is Vy. In all case, we can split the velocity V into two components using triangle law or parallelogram law. Here also, this is the velocity V. That is the combination of, or the resultant of ux and Vy gives the path like this. It moves the body through the parabolic path. That is a projectile motion. Okay. Thus, the main point is projectile motion is a motion with horizontal motion with constant velocity. This is the main point. Motion with a horizontal motion with constant velocity and vertical motion with constant acceleration, constant acceleration. Okay, at maximum height, another point, note the point, at maximum height, maximum height Vy equal to 0 and Vx equal to Ux, it is constant equal to U cos theta. That is, at maximum height, vertical velocity is 0 and horizontal velocity U cos theta. Are you clear? Okay. Yes. This is the path of a projectile and the horizontal and vertical velocity. Projecting an angle with theta with initial velocity u. At this point, horizontal velocity ux, vertical velocity uy. At the maximum height, a ux is the horizontal velocity, vy equal to 0, vertical velocity 0. At this point, ux horizontally and vy vertically downward. Okay, now we have to discuss some important terms related to projectile motion. First one, time of flight. We have to derive some equations. Mainly, we have to study three derivations. First one, time of flight. Second one, horizontal range. And third one, maximum height. Okay, we can derive these equations. First one, time of flight. Time of flight means the time taken by the projectile to complete the flight. That is, to move maximum height and reaches the ground. Time taken by the body to complete the projection is called the time of flight. We can solve any of the equation in two dimension using any one of the two component. We have two component, x component and y component. One, x directional motion, horizontal motion and vertical motion. We can consider any one. Okay. First one, time of flight. To calculate time of flight, we can consider vertical motion. Vertical motion. Time taken is same for both vertical and horizontal motion. Okay. Then we can consider any one. We select vertical motion to find the time of flight. In this vertical motion, consider the motion of the body from O to B. Okay. At maximum height, vertical displacement equal to 0. At maximum height, vertical displacement equal to 0. First, we have to derive time of flight. Time of flight is a time taken by the body to complete the projectile. That is, the body move from O and reaches at B. The time taken by the body to reach at B is called the time of flight. We can use vertical or horizontal motion. Consider vertical motion. Vertical. In this projectile motion, we consider vertical motion of the projectile, the displacement of the projectile. Vertical displacement, what is the initial point here, what is the final point here, that is same vertical height, that is vertical displacement equal to 0. Vertical displacement equal to 0. Vertical velocity uy equal to u sin theta. Initial velocity u sin theta. We can take a equal to minus g because the body thrown upward, a is equal to minus g. Time can be taken as time of flight. We can take capital T, time of flight. Then we can choose any one of the three equations from equations of motion. Which equation we select? Yes, we can select the equation S is equal to ut plus half at square, and put the values of each term. What is as vertical displacement? What is as vertical displacement equal to 0. S is equal to 0. U equal to u sin theta. A equal to minus t. T is equal to t. Put these values in this equation. 0 equal to u sin theta into time of flight capital T plus half into a is equal to minus j into t is equal to t square. That is u sin theta into t minus half gt square. We have to find the equation of time of flight t. So bring this term towards left. Half gt square is equal to u sin theta into t. This t and t square will cancel. G by 2 can place here. T is equal to, we get T is equal to u sin theta g. When we move g here, this denominator to numerator, that is t is equal to 2u sin theta by g. This is the equation of time of flight. Time of flight t is equal to 2u sin theta by g. Once again, please note, very important derivation. Derive an equation for time of flight of a projectile motion. Time of flight of a projectile motion. Consider the vertical motion. Vertical displacement equal to 0, because vertical displacement means the body completes its motion and it reaches the ground. So vertical height S is equal to 0. And a vertical velocity uy equal to u sin theta. A equal to minus g because moving upward. T is equal to time of flight t. We choose the equation S is equal to ut plus half at square and put the values in this equation. S is equal to, put the values. S is equal to 0, ut equal to u sin theta into t, half at square equal to half into minus g into t square, minus half gt square. We bring in left side, half gt square equal to u sin theta into t. Therefore, we get t is equal to 2u sin theta by g. 2u sin theta by g. Okay. Next, we have to find the horizontal range. Horizontal range. Horizontal range means the horizontal displacement. Horizontal range we denote the letter R. Horizontal range is the horizontal displacement of the projectile. We know horizontal motion is a constant uniform motion. Only one velocity u cos theta. For uniform motion we have only one equation, which is the equation for uniform motion. The equation of uniform motion is, yes, uniform motion. Equation of uniform motion, the displacement is equal to velocity into time. Velocity into time. Therefore, the displacement or the range r is equal to velocity, that is only one velocity ux, and time, what is the time? Time of flight. Put the values. What is ux? Ux equal to u cos theta. What is t? T is equal to, just we derive the equation. T is equal to 2u sin theta by g. 2u sin theta by g. Therefore, r is equal to ux equal to u cos theta, and t is equal to 2u sin theta by g. 2u sin theta by g. Okay, that is 2u into u square. U square. Remaining term 2 sin theta cos theta. I put it in a bracket. 2 sin theta cos theta by g. What is 2 sin theta cos theta? You studied in mathematics. What is 2 sin theta cos theta? Yes, it's equal to sin 2 theta. Sin 2 theta is equal to 2 sin theta cos theta. You studied in mathematics. Okay? Yes. Then we can write r is equal to u square sin 2 theta by g. U square sin 2 theta by g. Very, very important derivation. Yes, we studied two derivations from projectile. One is time of flight. What is t? T is equal to 2u sin theta by g. And next one, horizontal range, r equal to u square sin 2 theta by g. U square sin 2 theta by g. When this range becomes maximum, suppose you are projecting a ball with an initial velocity u and making an angle theta with horizontal. U and theta are constant. We can change the angle. The range becomes large. Okay. When the range becomes maximum, which angle? Maximum value of sin 1. When? Sin 90. That's 2 theta equal to 90. 2 theta 90 means theta equal to 90 means theta equal to 45 degree. That is, when we throw the ball at an angle of 45 degree, then r is equal to u square by g. This is the maximum range. Then what is the equation of maximum range? R is equal to u square by g when it get at a 45 degree. For a projectile, to get maximum range, we should project the body at an angle of 45 degree. Remember, It's important point, 1 mark question. Maximum range equal to u square by g at an angle 45 degree. Projection at a 45 degree. Next we have to discuss the maximum height, third. Okay. What is maximum height? Maximum height is this vertical displacement. This vertical displacement is called the maximum height. We have to derive this maximum height by considering the vertical motion alone. The vertical motion. Consider the vertical motion. We have to derive the maximum height. We can represent h. For vertical motion at a maximum height, vertical velocity Vy equal to 0. S is equal to maximum height h. Uy equal to u sin theta. A is equal to minus g. Okay, we can choose the equation. Choose the equation. V square equal to u square plus 2as, or v square minus u square equal to 2as. V square minus u square equal to 2as. V square equal to u square plus 2as. What is v? What is v? 0. For maximum height, vertical velocity v by 0. S is equal to h u by u sin theta. Put these values in this equation. We got the derivation. 0 equal to u sin theta, u square equal to u sin theta all square minus 2gh. A is equal to minus g. That is 2gh equal to, bring the minus 2gh to left side. We got 2gh equal to u square sin square theta. That is h equal to u square sin square theta by 2g. This is the equation of maximum height. It's the equation of maximum height. Okay. When the maximum height becomes maximum, which angle? Yes, at a 90 degree. At a 90 degree means it is a vertical motion. It's one dimension. Okay, when theta is equal to 90, then h max equal to u square by 2g. This is the equation for one dimension for vertical motion. You already studied in the first chapter. Okay, yes. Then we studied important 3 derivations. First derivation, time of flight. What is time of flight? Time of flight is the time taken by the projectile to complete its projection, its flight. We got t is equal to 2u sin theta by g. 2u sin theta by g. Second one, horizontal range. What is horizontal range? The horizontal displacement of the projectile. R is equal to, we get u square sin 2 theta by g. You must study thoroughly both equations and derivation. Both are important. Okay, maximum height equal to u square sin square theta by 2g. Okay, three equations. First two initially, second two at the middle, third two denominator. Just remember TRH, time of flight, range, horizontal, maximum height. Okay, one more thing is not important, but we can study the time taken to reach maximum height. The time taken to reach maximum height. Time taken to reach maximum height. That is the time taken to reach here. You have to find this T. We know V is equal to U plus AT. At the maximum height, V is equal to 0. U equal to U sin theta. A is equal to minus G. T is equal to maximum height. Time taken to maximum height, we can denote Tm. That is G Tm equal to U sin theta, or Tm equal to U sin theta by G. This is the time taken to reach maximum height. What is the time of flight? Compare this to time of flight. T is equal to 2u sin theta by G. Time taken to reach maximum height, u sin theta by G. That is half of time of flight. Half of time of flight. Then the second half, yes, it is taken by to reach the ground, from maximum height to ground. Upward is called ascending, downward is called descending. Time of ascending is 2u sin theta by G. Time of descending also 2u sin theta by G. Time of ascending means time of rise. Time of descending means time of fall. If we neglect the air resistance, then it is equal. Time of ascent equal to time of descent. Okay. Now, we studied horizontal range R equal to u square sin 2 theta by G. U square sin 2 theta by G. Okay. Is it possible two angle of projection for the same horizontal range? It's a question. Is it possible for a velocity u, same range with two angle, that is like this? One projection, it's an angle theta. It is another projection. Both the velocity same, u. Velocity u same, initial velocity same, but the angle different. This is theta, this is another angle. Which angle? We have to find out. This is the range R. Same range for two angle of projection. We know sin 2 theta is equal to sin 180 minus 2 theta. Okay. Trigonometric relation, sin 2 theta is equal to sin 180 minus 2 theta. We can take, so we can write this equation, equation number 1 as R is equal to u square sin 180 minus 2 theta by G. Okay. 2 theta can change 180 minus 2 theta. That is r is equal to u square sine, take 2 outside the bracket, 2 into 90 minus theta by g. R. What is r? R is equal to u square sine 2 theta by g. 2 theta by g. That is u square sine 2 theta by g equal to u square sine 2 into 90 minus theta by g. That is, instead of theta we can put 90 minus theta. We got the same range. Okay. That is, if we project the body with an angle theta or 90 minus, with an angle theta or 90 minus theta, we got the same horizontal range without changing the velocity. Without changing velocity, we can throw a body with two angle and got the same range. But maximum height is different. Here maximum height is less than the second. For more angle, maximum height more. Okay. This is the question. Please note. Okay. One more to prove. The first we studied the path of a projectile or trajectory is a parabola. We have to prove this. The equation of a parabola is parabola. What is parabola? Yes, parabola, this shape. The equation of parabola is y is equal to ax plus bx square. We have to prove the equation of projectile is y is equal to ax plus bx square in that form. Equation of a projectile. Very, very important derivation. Listen very carefully. We have ux equal to u cos theta. Okay. Time taken t. You can t. Horizontal displacement x equal to u cos theta into t because it is a uniform motion. Velocity into time. Displacement equal to velocity into time. X equal to u cos theta into t for horizontal motion. We have ux equal to u cos theta. Consider the horizontal motion along ux equal to u cos theta, constant velocity. We can write x equal to horizontal displacement x equal to, yes, it is uniform motion, velocity into time, that is u cos theta into t. Therefore t is equal to, we can write t is equal to u cos theta taken as denominator, x by u cos theta, equation number 1. This time is same for both horizontal and vertical. Now consider the vertical motion. Y is equal to u sin theta minus u sin theta into t minus half gt square. How we got? S is equal to ut plus half a t square. Here s is equal to y, u equal to u sin theta, t equal to t, a equal to minus g, therefore minus half gt square. That is this equation. Okay. Now put the value of t in this equation. X by u cos theta. We got y is equal to u sin theta into x by u cos theta minus half j into u cos theta x by u cos theta all square. That is sin theta by cos theta. What is this? U sin theta by u cos theta. U and u will cancel. Sin theta by cos theta. Tan theta into x minus half g into x square by u square cos square theta. That is y is equal to tan theta into x minus g by, we can take 2 in bracket, 2 u square cos square theta into x square. Look this equation. Theta, the angle of projection. For one projection, theta is constant. U, initial velocity. For one projection, it is also constant. G is constant at a place. At a place, G is constant. Therefore, theta, G and U are constants. Theta, A and R, theta, G, U, A are constant. Then what is the variables x and x square? Thus we can write y is equal to ax plus bx square. What is a? Yes, this is a tan theta. What is b? Minus of g by 2 u square cos square theta is b. Y is equal to x plus bx square is the equation of a parabola. Therefore, this equation gives that the trajectory of a projectile is a parabola. Okay. Then we show that the equation of a projectile is a parabola. This is also an important question. Show that the path of a projectile is a parabola. How to prove this? Yes, just look once again. Equation of a projectile, parabola. Look here. For vertical motion, for horizontal motion, ux equal to u cos theta. For horizontal motion, very important. For horizontal motion, ux equal to u cos theta. X equal to horizontal displacement equal to u cos theta into time. That is displacement equal to velocity into time. This is the equation. Thus we get time t is equal to x by u cos theta. Time is time for both horizontal and vertical. Then vertical displacement y is equal to u sin theta into t minus half gt square by putting the values in. S is equal to ut plus half at square. Here we get. Then y is equal to u sin theta into x by u cos theta minus half g into x by u cos theta all square. Substitute the value of t from equation number 1. We get tan theta into and u sin theta into x by u cos theta minus half g into x by u cos theta all square. U sin theta by u cos theta equal to tan theta, and we put these values in bracket and we got the equation like this. Okay, this is the equation. This equation represent the equation of a parabola. This topic is very important. The projectile motion we studied here. Mainly 3 derivations is some important points. First thing, for projectile motion, it is a combination of 2 motion, horizontal motion with a constant velocity and vertical motion with a constant acceleration. Second one, at a maximum height, horizontal velocity u cos theta constant, at a maximum height vertical velocity vy equal to 0. and we derive 3 equations: time of flight, horizontal range, maximum height. All derivations are very, very important, and also derive time taken to reach maximum height. It is half of the time of flight. Then we can say that time of ascending equal to time of descent only if we neglect the air resistance. Okay, and last and also we prove for 2 angle we got same range for same initial velocity, but different angle we got same range. What is the angle? Theta and 90 minus theta. If one angle is 30 degree, then the second angle is once again. Please note. If one angle of projection is 30 degree, then the second angle is 60 degree. 90 minus 30, 60 degree. We got the same horizontal range. We also prove this. And last, finally we prove that the path of a projectile is a parabola. Okay, the equation of a parabola is y is equal to x plus bx square. We prove the equation of projectile also. Y is equal to tan theta into x minus g by 2 u square cos square theta into x square. That is in the form of y is equal to x plus bx square.